Hey guys, welcome to our weekly live stream. This is the live stream for college algebra, and this week we're going to be looking at lessons 4 through 9. We're going to be looking at systems of equations, testing for symmetry, and I'm hopefully going to get to an example on variation, which you may or may not have already watched the video lecture for. If not, maybe take some notes and take that with you for when you begin that lecture in the next day or so. If you guys are joining us and you're logged into YouTube, if you can just go ahead and type your name into the chat field, that way we know who's here and we get an idea of who's participating with us. If you're on a mobile device, you'll want to look at the very bottom of your screen. There should be a bar that says chat that you can type into. But we just want to know who's out there, and please feel free throughout the stream to ask questions. Even if there's a bit of a delay, I can always go back and address those questions after the fact. So let's go ahead and get started. We're going to jump around a couple questions just to make sure that we get through everything. But the first question we're going to deal with has to do with symmetry and testing whether or not an equation is symmetric with respect to the x-axis, the y-axis, and the origin. So for this equation, y equals 3x over x squared plus 9, we're going to first test for symmetry with respect to the x-axis. Maybe. I don't really want to write in red. That works. To test for symmetry with respect to the x-axis, you're going to take all your y values and replace them with negative y and then simplify. So we've got negative y equals 3x over x squared plus 9. Now to compare this to our first equation, we want to get rid of the negative on y, so I'm going to multiply both sides by negative 1. So we get y equals negative 3x over x squared plus 9, which we can clearly tell that that's not the same as our original equation, so it's not symmetric with respect to the x-axis. Now let's test for symmetry with respect to the y-axis. To test for symmetry with respect to the y-axis, we're going to replace all of our x values with negative x values. Make sure that when you're substituting in a negative x or any negative number that you use parentheses. So we have y equals 3 times negative x over negative x squared plus 9. When I simplify this, this becomes negative 3x over negative x squared is the same as positive x squared plus 9. And again, when comparing this to our original, it's not the same, so it is not symmetric with respect to the y-axis either. So now we have to test for symmetry with respect to the origin. Had we tested yes for both the x and the y-axis, then we automatically know that it's symmetric with respect to the origin. But in this case, since we don't know about symmetry with respect to x or y, we do need a test for the origin. But before we do that algebraically, I do want to just highlight one thing. Look at what we ended up with in both of those two tests for symmetry. We ended up with the exact same equation. That is going to indicate that it is symmetric with respect to the origin. Now, to verify, we will test algebraically. So to test for symmetry with respect to the origin, we're replacing both x and y with negative x and negative y, respectively. So we've got negative y equals 3 times negative x over negative x squared plus 9. Negative y equals negative 3x, excuse me guys, negative 3x over x squared plus 9. And so that we can compare more clearly, we're going to multiply both sides by negative 1, so we get y by itself. We get y equals negative 1 times negative 3x is positive 3x over x squared plus 9, which matches our original equation. So yes, it is symmetric with respect to the origin, which we had already thought was going to be the case because we had those two matching equations in the first two tests. Solving a system of equations. We're going to go through one of these. These are quite time consuming. Remember the first step when you're solving a system of equations with three unknowns, you want to observe and look at all of your variables and their coefficients so that you can identify which variable you want to eliminate first. So for this, I'm looking at either my y's or my z's because we have opposite signs. In my notes, I went ahead and eliminated y, so I'm going to stick with that. So let's start with combining equation 1 and 2 to eliminate y. Now, in order to eliminate my y values, we need to get a 3y here. So I'm going to multiply my first equation by 3, and I'm going to combine that with my second equation to eliminate y. So we have 3x plus 3y minus 3z equals negative 3. And my second equation stays the same, 4x minus 3y plus 2z equals 16. When we combine these, we get our fourth equation. We get 7x. The 3y's cancel out, minus z equals 13. This is going to be equation 4. Now we want to choose two different equations to eliminate y again. We already used 1 and 2, so we can either use 1 and 3 or 2 and 3. We're going to go ahead and use 1 and 3 again so that we don't have to multiply both equations. So if I'm using equation 1 and equation 3, I need this one to look like a positive 2y, so I'll multiply my first equation by 2 and combine it with equation 3 to eliminate y. So our first equation multiplied by 2 is 2x plus 2y minus 2z equals negative 2. And my third equation, 2x minus 2y minus 3z equals 5. I'm going to combine these two equations to get my fifth equation. We have 4x minus 5z equals 3. Remember, guys, if you have any questions throughout this, you can type them into the chat field. That way we can address them as we're working through the problem live. I'm going to clear this. I'm going to rewrite a new system with equations 4 and 5. So my new system is 7x minus z equals 13. And 4x minus 5z equals 3. And this new system we can solve using substitution or elimination, whatever your preference is. Since I've got a lot of coefficients, I'm going to stick with elimination, and I'm going to try to eliminate z. In order to do that, I want to multiply this first equation by negative 5. When I do that, I get negative 35x plus 5z equals negative 65. 4x minus 5z equals 3. That equation stayed the same. When I combine these, we get negative 31x equals negative 62. X is equal to 2. Now to find our next variable, we're going to take x equals 2, and we're going to substitute it back into one of those two equations with x and z. I'm going to use 7x minus z equals 13. So 7 times 2 minus z equals 13. Subtract 14 from both sides. Negative z equals negative 1. So z equals positive 1. So now we have x equals 2. We've got z equals 1. I'm going to erase this so that I have some more space. And I'm going to plug those two values into one of my original equations. So using x plus y minus z equals negative 1. X is 2. We don't know the value of y, and z was 1. Let me get back to white. I think it's easier to read for you guys. So 2 minus 1 is 1 plus y equals negative 1. Subtract 1 from both sides, y equals negative 2. So our answer is 2, negative 2, 1. Guys, remember the tips that we've discussed in class and in your video lectures. When you get to a point in the system of three unknowns where your answer seems a little odd, or you get to a result that just doesn't sit well with you, you're like, that seems weird. Stop where you're at and check your work. There are so many places, so many tiny little instances where if you make one baby mistake, it's going to throw the entire problem off. Okay, so when you get to a point where you're like, that doesn't seem right, check your work. Now, hopefully we're going slow and checking as we go, but sometimes things get away from us. So you want to make sure that you practice identifying where you're making your mistake as you're going. So this next example, we're not going to go through the whole thing, but we're going to set up the system, finding real numbers a, b, and c so that the graph of the quadratic function contains the following points. Now the graph of a quadratic function is y equals ax squared plus bx plus c. So we're going to come up with 3 equations that fit that using these 3 points. Now each of our ordered pairs is an x and a y. So we're going to plug them in for x and y in here so that we end up with equations with variables a, b, and c. So our first equation is going to be negative 4 equals a times negative 1 squared plus b times negative 1 plus c. Our second equation, 6 equals a times 1 squared plus b times 1 plus c. We use that ordered pair 1, 6. For our third equation, we're using the point 3, 0. So y equals 0 and x equals 3. A times 3 squared plus b times 3 plus c. Now notice in this first step, I just did the direct substitution. I will worry about simplifying next. A lot of times we try to combine these steps and then we make some careless mistakes. So we want to avoid that as much as possible because, like I said in the last example, one tiny little mistake is going to change everything. So we want to just be really careful. When I simplify these and rewriting it so that my variables are on the left and my constants are on the right, because that's what we're used to, this looks like a minus b plus c equals negative 4. A plus b plus c equals 6. And 9a plus 3b plus c equals 0. And we can solve this system just like our previous example when we had x, y, and z. The solution for this, if you guys want to go ahead and try it on your own, we get a equals negative 2. B is going to be 5, and C will be 3. So if you want to try that one as some extra practice, there's the answer so you can check your work. I'm not getting any questions from you guys, so either we really know this stuff and my lecture videos are super awesome, or you're being a little shy. Guys, we really appreciate your interaction, and it's best for everybody. Everyone wins when we ask the questions because chances are if you have a question, somebody else has the same thing. And hey, maybe I'm making a mistake. I'm human too, and I need you guys to call me out on it so that I'm not giving you guys false information. Solving systems of nonlinear equations. We're going to go through one of these. There's another one, but if we have extra time, we'll come back to it. X squared plus y squared equals 13. X squared minus y equals 7. Actually, I'm going to do the next one. I think we did this one in class today. So let's look at this next one. 3x minus y equals negative 2. 2x squared minus y equals 0. When we have a system of nonlinear equations, we have the same options, substitution or elimination. Remember that with elimination, you have to eliminate an entire variable, which means any occurrence of that variable. So if I've got an x and an x squared, I'm not going to be able to eliminate my x terms because they're not like terms. There's 3x and the 2x squared. I can't cancel them out, okay? But I could possibly eliminate the y terms because they're both just y to the first power. So let's try that approach. We want to eliminate y, so let's multiply one equation by -1. We'll use the first equation. So we end up with -3x plus y equals 2, and 2x squared minus y equals 0. And if you guys want to give yourself some more space, let me show you real quick what I'm talking about. Maybe writing that 2x squared over a little bit will help keep you guys from trying to combine those x terms that are not like terms. So the y's are going to cancel out, but when I start combining like terms, we see that we've got 2x squared minus 3x equals 2. When we see this equation, we automatically need to be thinking set equal to 0 so that we can try to factor. We're going to subtract 2 from both sides. We get 2x squared minus 3x minus 2 equals 0. I just realized I made a mistake when I did this problem originally, so we're going to see where this goes. I haven't done this one yet. At this point, we want to factor. Now, we can use trial and error here because my first term is prime, so I know that my only options are 2x and x. Factors of -2 are 2 and 1, and I need my middle term to be -3. So maybe I want to try 1 and 2 here. That would give me 2x and another 2x. That's not going to give me 3x, so that's not going to work. Let's try again. Maybe we do 2 and 1. That's going to be 4x and 1x, which could give me 3x. So now let's play around with the signs. Hey, Anna, I'm glad you're here. Hopefully, if you have any questions, make sure you type them, and we'll address those as we're going. I want a -3x, so I want -4x and positive 1x, and the negative and the positive on our two constants will give me that -2. I'm going to quickly just take a tangent here and show you the AC method for factoring. If we've got 2x squared minus 3x minus 2 equals 0, we're looking for factors of a times c, which is -4, that sum to -3. So that's going to be 4 and 1, where we want 4 to be negative and 1 to be positive. Now we're going to take those factors and rewrite our quadratic. So we've got 2x squared minus 4x plus 1x minus 2 equals 0. Notice what I did from here to here. It's the exact same quadratic, but I took that middle term, that -3x, and I split it up as -4x plus x, and those coefficients, the -4 and the 1, came from these factors right here. At this point, we're going to factor by grouping. I can factor a 2x out of the first. I'm left with x minus 2. Over here, I can only factor out a positive 1. When I do that, it doesn't change the second factor. It's x minus 2. And that gives me one factor is x minus 2. The third factor is going to be, the second factor is 2x plus 1, which matches exactly what we had over here. But if you haven't been taught the AC method, this is a really great way if you like a more systematic approach to factoring. I'm going to erase this. Get back to the problem at hand. All right, so we've got our factors. We can find our values of x. X equals -1/2 and x equals +2 by setting each of our factors equal to 0. And now that we have two x values, we want to go back and find our y values. So we want to plug each of those back in. And we're going to use that linear equation, that first one. So over here, when we plug in x equals -1/2, it looks like 3 times -1/2 minus y equals -2, or -3/2 minus y equals -2. We add 3/2 to both sides. We get -y equals negative 1/2. I hope that's right. I'm doing that pretty quickly. And we get y equals positive 1/2. I have a question on the board. You can maybe see it on the screen. Could we have eliminated y if the operation before was different? So we did start by eliminating y, Luke. If you see, that was what we did in this first step right here. That was eliminating y. Maybe you meant to ask, could we have eliminated x? And we talked about that. So if you're just tuning in, when you're using elimination for nonlinear systems, you need to make sure that you can eliminate every occurrence of that variable. So in my original problem, because we had a 3x and a 2x squared, since those are not like terms, combining them is never going to get them to cancel out. So I hope that answers your question, Luke. I'm going to keep going with this. So we found when we plugged in x equals negative 1/2, we got positive 1/2. I'm hoping that that's right. So one solution is negative 1/2, positive 1/2. And now we do the same thing with our second value of x, which was 2. So we have 3 times 2 minus y equals negative 2. 6 minus y equals negative 2. Subtract 6 from both sides. Negative y equals negative 8. Y equals 8. And that yields our second point of intersection, which is 2, 8. So we have 2 solutions for this one. And I want to just emphasize one of the things I just quickly said, and that was we're locating the points of intersection. Okay, we're dealing with a quadratic equation and a linear equation, so something like a parabola and a line. If I think about those two shapes, the most we're going to have are 2 points of intersection, which is what we have here. We could have no points of intersection. We could have 1 point of intersection if they were tangent to one another. I think that's it. Hopefully I didn't make any mistakes. I don't have the correct work here, but if there's any issues, please let me know so that I can address it in class. All right, so we have just a few minutes left, and I've got a couple examples of variation. I'm going to go ahead and talk about them a little bit, but understand that if you haven't watched the video, maybe it's not going to be very meaningful to you. Take some notes and then maybe come back and revisit these problems after you've watched the lecture video. The monthly payment P on a mortgage varies directly with the amount borrowed. So this first statement is indicating how we're going to set up our model. And specifically, we're paying attention to the direct variation. Direct variation between two variables means that P is equal to some constant times your second variable, whatever it varies directly. So this relationship says that P varies directly with B. In the next example, we see an inverse variation, and that's set up a little bit differently. But direct variation, you're multiplying. So they tell us that a monthly payment is $6.49 for every $1,000 borrowed. So P is equal to $6.49 when B is equal to 1,000. I can substitute these two values in, and that will allow me to find K, which is our constant of proportionality. So we've got 6.49 equals K times 1,000. If I divide both sides by 1,000, K is equal to 0.00649. Do not round here, guys. This decimal terminates, use the entire thing. So now we actually have an equation that relates the monthly payment to the amount borrowed. The monthly payment is equal to 0.00649 times the amount borrowed. We can use this now to answer the question asking us to find what's the monthly payment when the amount borrowed is $145,000. We plug in our value of B. And you guys can do this on your calculator. We get that our monthly payment is $941.05. So let's look at the next one, and then I'm going to come up and summarize a little bit with the variation problems and how to approach those. The electrical resistance of a wire varies directly with the length of the wire and inversely with the square of the diameter of the wire. So again, this first sentence is how we're going to set it up. Okay, we're dealing with three variables here. We've got electrical resistance, and that's varying directly and inversely with some other stuff. So the electrical resistance is what's on its own. So we're going to call that R. It varies directly with length. So K times L shows that direct variation. We're using L for length. And inversely with the square of the diameter. An inverse relationship, if Y varies inversely, we use division. So Y equals K over X is how we would show that Y varies inversely with X. So if R varies inversely with the square of the diameter, that means the square of the diameter needs to go in the denominator. Careful of this. This says square of the diameter. We're going to use D for diameter, so this is D squared. Once we do this, now we're going to continue plugging in some values. We want to solve for K, which is exactly what we did in the last example. If you notice, we always start by setting up this equation with a bunch of variables, and then we're given all but one, which is K. We plug those in, and that allows us to find K. Once we have K, then we can use other information to find one of the unknown values that are actually related to the problem. So in this case, the electrical resistance, the length, or the diameter of the given wire. So here we have a wire is 42 feet long. So they're giving us the length is, 432 feet. The diameter is 4 millimeters. And the resistance, the electrical resistance for that is 1.24 ohms. So I can plug these values into my model to solve for K. So 1.24 equals K times 432 divided by 4 squared. To solve for K, we're first going to get rid of the denominator, so we're going to multiply both sides of this by 16. And 16 times 1.24 is 19.84. And that's K times 432. Let me show you that step. I multiplied both sides by 16, and that's what got rid of the 4 squared. Now I want to divide both sides by 432. And when you do that, you get a pretty long decimal. I'm going to round it just for the sake of keeping track, but you should keep it in your calculator. So it rounds to about 0.046. So now I can set up my model. My model is R equals 0.046 times L divided by D squared. Now using this, we can plug in to find the length of a wire whose resistance is 1.44 meters. So they're giving us the resistance is 1.44 ohms, The diameter is 3, and we want to find the length. The length is what we don't know. So we can plug this in. 1.44 equals 0.046 times L divided by 3 squared. Now to solve for L, you're going to go through the exact same steps that you would for that we used to solve for K because they're both in the numerator. We'll start by multiplying both sides by 9 to clear the denominator, which gives me 12.96 equals 0.046 L. Now, in most cases, hopefully you're dealing with the opportunity where you're not actually going to use the 0.046. You're going to use the exact value, which was that long decimal. That might require you going back and recalculating this. Your calculator does have short-term memory, and most of your scientific calculators, you have the ability to store numbers in. If you're interested in finding more about that, then we can talk about that during office hours, or you could use Google or YouTube to search for how to do that on your particular model. But here we want to keep this as exact as possible. Generally speaking, we always want to wait to round until the very end. So that 0.046 is already rounded. If we leave it there, we're going to round even further at the end, which takes our answer and, makes it even less accurate. So dividing both sides by the actual value of k, not that 0.046, we get L is equal to 282 feet, 0.194, 282.194 feet. That's an L, not a 2, just to clarify. So to summarize, with these variation problems, the first thing you guys are going to do is set up that model. So that has to do with the rules. What does direct variation mean? What does inverse variation mean? Once you set that up, then you're plugging in values to solve for k. Once you have k, then you can set up your actual model. Okay, we need to know what k is first. Once we have the model, then we can solve the question or solve the problem, whatever they're asking for. But you'll find that every one of those follows that exact same sequence of steps. Setting up our model, plugging in to solve for k, and then once we have k, we can find some other unknown value. You guys are due to watch lesson 9 sometime today, certainly before class next week. So please make sure that you take a look at that. Bring any questions you guys have, and remember that our first test is next week. So you want to be taking a look at your review in the meantime. Bring any questions you have to class, emailing me, taking a look at videos over again. Whatever you guys need to do, there's lots of resources, and hopefully you're using this as one of them. So good luck in the next couple days getting ready for your test, and we will see you guys next time. Have a good day.